Okay, this is a quick demonstration of a new motor controller configuration. These are using TIP 142 and TIP 147. They're rated at 10 amps and 100 volts, and they are the best I can get for a dual drive diesel, you might say, or a large motor steam engine. That's half throttle, not doing too bad. I can pull it down a little bit. Pull it down. That's 70. Harder. I'm probably not going to try at 80, 90, or 100. Mine only goes up to 100, but that's full throttle. That's about 15 volts. Nice and cool. Everything's running smoothly. Go to neutral. Go to reverse. Went too fast. Reverse. This is a converted field set by Jim Shea. He's routed out the old winding area and put in some magnets. As you know, we have the plastic fields with the magnets. He put his magnets inside the big field there, and that works great. But when I need to add sensors, I have to have a flat top, and that's why we go with ours, because I need sensors down here. But what you're seeing here is a pretty basic system. This is the rectifier. It takes AC to DC, and it passes the DC onto this motor control board, which then takes that input, and depending on the direction of the signal, it will create forward, neutral, reverse, forward. So that was, I don't know if that was reverse or forward. I guess that was reverse. This is forward. So you go forward, neutral, reverse, neutral, forward. Okay. So it shifts exactly the same as the old Flyer does, except for its direct current. It's AC to the track, DC out of here, and a DC to the motor. So this would be a CAN. If you happen to have a CAN motor laying around, I have a few. This is an oldie but a goodie, right? Frank's contraption. And I have several others from SNS as well. And we make our own DC conversion. This is another one that Jim Shea did, one of his earlier ones. And there's another one that we did. And here's one we're working on. And this was the reason why I built this controller with 10 amps. We're going to try that baby out. Okay, that's the show, Joe. What I wanted to show you was we have this adapter. Let me turn this off. And if I can bring this over here graciously. Okay, there we go. Roll it over. And what you can see is we've designed this plastic plate to fit on top of this tender with a pair of pins for alignment and then a single screw to hold it down, and that gives you a stable, secure, insulated location, and then the chassis body just slides over it, and this fits in the rear of the tender, and that leaves the front open for a sound system if you want, or a smoke controller. You need an 8-volt regulator for that, and so this thing can hold probably a simple soundboard and 2-volt regulators, one for the soundboard and one for the smoke. And then those can also run LEDs front and rear. Okay, so this, oh, I took it way over here. Hold on. I was looking at this earlier. When I get done with this test I'm doing now, I'll be able to take this controller and fit it in here and route these motors as if they're DC and see if I can run these universal motors in DC. I don't know if I can or not, but we're going to give it a shot. I don't know if I can do everything in one hand, but I guess I can. I can do it one-handed enough. Not very good. Very right. You get the idea. I can put the reverse unit up here in this cavity, and I think I should be able to run these motors or any DC motor if I wire them properly, right? So the fields and that are wired the same. Then, now I'm thinking about it. I'm not sure if I can or not. Then, what was I going to say? Oh, I could do, oh, I know what I meant. I can get the B unit and put the sound system in the B unit. Absolutely. The sound system is not that big. These two little boards here are what's for the puff sound, which chuff sound, which you're not going to use on the diesel, but you would on the steamer. So that has to go in the steam engine, right? You know, and this is the there's what the assembly would look like from a framing point of view, and how this works. This fits in here like this. The hole goes over that hole for clearance. And the boards get screwed to this, and this is your insulator and installation adapter. Okay? And when we get bigger, more custom engines, we build them. We just build the whole chassis. Look at that. We just build the whole chassis up and mount everything, and then we can use this for smoke and control. This one has no sound yet. This one just has a smoke controller and a DC drive motor. Those are the old TIP transistors. This one has the newer TIP transistors. Notice the heatsink. I put them on, but I don't need them. It's okay. We have another version that we're going to be putting out, 102s, 107s. That's an 8. These are 10s. These are probably only going to be used on diesels. They're expensive, and they're 10 amps. Who needs 10 amps, right? The other components will go before these, which is good. That's okay. All right, that's what I wanted to share. This is the module, you say. This is a digital reverse module, and it includes a motor control board for reverse and a power distribution board for AC to DC, and then distributing that power out. That's it. Fits under the tender on the back side, the water side. There it is again in a different configuration, and this is how the plastic parts. I make these here, and then we assemble the boards, or stick the boards on, wire them up. So when you get it, you get this. You actually get this piece right here, and the target is $25, but I'm not sure we're there yet. We're close. I'll let you know. I'll let you all know. Okay, I'm going to post this because it's common. It's out there. It's what we're doing, and we need to let everybody know. Now it's 4:30. I have to get back on what I was supposed to be doing today. All right, later.